This conference will now be recorded.
Yeah. All right. Hi, folks. Everyone. This is the monthly hardware management project meeting for April 18th, 2023. Let's see. I can share my screen. We've got a number of things on the agenda, and I'm going to move some stuff around because we've got folks that want to do presentations, so we want to get through those. Let's see. Share. Sorry, I have to click through all of these. There we go. All right, so there is, I think Hemel had updated the meeting agenda. Let's see, I'm trying to get all of the, there's my people list. Wow, that's annoying. Okay. All right, so the topics for today, we have a presentation from, and it's kind of down here, but we have a presentation from Lenovo and Cloudflare on the DCSCM module. And I see Sammer's on, but Sammer, we had another presentation. We were going to defer that one. Is that correct? Sammer was there.
Yes.
He may be double muted.
Yes. Sorry, the unmute took a long time in the browser. Yes, that's deferred, please.
Okay. All right. And let's see the other, and we wanted to talk about the, we have our management tech talk this time next month. All right. So, anything else that we need to get to today? I mean, I think we've also got the RAS API feedback. I'm sorry, I'm missing that one. Here are the two that are big topics for today. Anything else that needs to be covered today?
Maybe a quick question, Jeff. Hardware fault management is ready with the contribution of fault handling infrastructure requirements. We want to take it to IC, and I just wanted to understand, you want us to present it here before we take it to IC, or how do you want us to handle that?
Yeah, I would. Yeah, we definitely do that, I think. But
hey,
hey, Hemel.
Hey, I don't know what, but I was having problem connecting. Can you guys hear me?
Yep.
Okay. All right, I think we have a number of people on the call. Let's go ahead and get started. Somebody is typing. Can you please mute? There's a lot of background noise. Okay. And
Hemel, we were just negotiating the agenda.
Yeah.
okay. All right. Do you want me to share my screen?
Yeah, I've already got it up, Hemel.
Okay. All right. So we got the one of the presentation may not happen today, but maybe that topic can be introduced by Sammer. Is that, did you discuss that?
Yes.
Okay.
Yeah. So the Hemel and I've highlighted the kind that we've got two chunks of time for today. We've got the Lenovo and Cloudflare presentation on DCSCM 2.0 and feedback, and some time for feedback on the RAS API proposal. We've got a lot of other updates and stuff, but I wanted to get those presentations up first, and anything else that needed to be discussed. And so I'm sorry, just when you came in, we were talking about I'm sorry, it wasn't the accelerator, it was the was it DCSCM? I'm sorry, we were interrupted. Don't remember who was talking.
This is the DCSCM 2.0 module, product spec reference design. Is that the one we are talking about?
No, there was somebody else was.
There was accelerated management.
Was the accelerator?
Okay. Yeah, this is the work stream proposal.
No, there was something that somebody was going to take something to the IC and wanted to know if they wanted to present here first, and I said.
Yeah, that was me. I was talking about hardware fault management.
The hardware fault. Okay.
Infrastructure requirements is ready for contribution, and I think we want to take it to IC. But since we meet only once a month, I was wondering, do we have any option rather than waiting till next month this time to come here first, or could we proceed in parallel? That's what.
Well, yeah, and so the next meeting is also a question because we've got that half day tech talk that's going to overlap here. So I mean, Hemel and I'm trying to remember if we had already planned to cancel the meeting next month, which was the day before that tech talk.
Either we cancel or we move it. Let's discuss that at the end.
Okay.
So, Jeff, I believe this. I'm taking notes today, and then you will be doing the May meeting. Is that or
That's fine.
okay? All right. So let's.
So regarding Yogesh's question on the table,
Yeah, we
so
can discuss it today if you have time.
no, well, the question is whether it needs to be presented at this project or whether it can go directly to the IC.
Yeah, I think so. I don't know how long is the presentation, Yogesh, but if we have time today, if we can at least get an overview of that here, that'll be
Right,
good.
because the philosophy is that the co-leads of this project not be surprised by anything that goes to the IC. It's not
Right,
necessary for this group to approve the document, just
right,
notification that the document is going.
right. I think I would. Yeah, that's why today, if we can get uh, basically this project can get an overview of what's going to IC, then
Okay,
we
so
should be.
we're gonna allocate some time for these three big items at the end, or go through them first.
I'd like to go
I
through.
think let's go through them first, and then we can cover the remaining updates and
Okay, let's do that.
okay. All right. So which one we are starting with first? I see Jeff, you're
Yeah,
adjusting
I'm just going to move all three of these up here.
okay. Okay. So Yogesh, I guess based on that, do you want to do both sub-project update and mainly just go over what's going to IC? How long do you need for that? 10 minutes, 15 minutes?
I can do that in 10 minutes, I think, because we're not going to go into details, and you all have seen the details in Global Summit, which is also recorded. So we're not changing a whole lot. Just wanted to flash the document that's ready and it's cleaned up,
Sure.
and much has changed.
Let's
You
go
want me
over
to
that.
start? Go ahead and share.
Yeah. Yes.
Okay.
And then we'll do the Lenovo cloud presentation, and then we'll talk about the feedback on RAS API.
Okay. All right. So you guys can see my screen now.
Yep.
All right. So I'll start with the status. Like I said, our fault handling infrastructure requirement is ready for contribution. We'll talk about it today. Another good development is fleet scale memory fault management, call it FM work stream. Group has been started. A lot of members have joined, a strong interest from DRAM vendors and um, CSPs and silicon vendors. What we are trying to achieve there is to standardize architecture for memory error handling and error telemetry. I won't go into much details of this today in interest of time, but this is just its first meeting is going to take place on April 25th, and that's when we'll formalize and go around, ask, prioritize our agenda. Okay. There's some interest in hardware error injection standardization. I have asked some folks who are interested in starting maybe a work stream to come up with a white paper, so we can formulate a strategy around that and see if there's a need for a work stream or how we want to work around it. That's a very good problem to attack. A lot of need for having a common method which different, so we can avoid fragmentation around different vendors. And the last one is we started collaboration after global summit with cloud service model team on in-band error handling. And they joined our meetings for a while, and some of our folks went there. But it seems like there needs to be done some work needs to be done to kind of reconcile different approaches to that. So yeah, that is something that I'll be working and focusing on a little bit to see how we can make it a common standard for OCP rather than different vendors proposing their different approaches. Now, coming to the document that I talked about that we've been working on, and this effort kind of started in smaller ways around 2 years ago, I think, when I joined this project. A lot of different smaller white papers we wrote around identifying the problems, identifying the types of errors, identifying different methods. Finally, it all came together as kind of a common infrastructure for handling fault management, which is kind of a vendor agnostic, works seamlessly across various hardware vendors and ingredient vendors. So it is about I think 35 pages document. I'll skip over. Can you guys read this, or is it too small?
We can see. Yep, keep
Okay.
going.
Yeah, I'm only going to go through table of content again, not through a lot of details. Like I said, details have not changed much from what we presented in the OCP Global Summit. Myself, Drew Walton from Google, and Vilash Sridharan from AMD. We presented the details of this proposal. Here is the table of content. Of course, we start with problem statement, give some background around various usage model that we have. We also give a very good and agreed upon. When I say agreed upon, this took a while between the OEMs and different CSPs to classify the errors and how what can be handled with what method and what's the right recommendation. So that is done, and then I think a diagram that we have created that is a vision of the. I'll just take it there for a quick second. So we kind of created this, and this has all been presented in our global summit. So basically, high-level concept is here, right? So there's a CSP infrastructure, and there's various standard logs that are coming from vendors interface to see, and sometimes passing through BMC or sometimes being analyzed there only. And we are working on various layers now, and that's why substreams are coming out, work streams are coming out, where we're working on different pieces problem. For example, what is the interface? What is the protocol for memory? What is the interface protocol? What is the analyzers for memory look like, which go here? What are the cloud level analyzers or tools that tooling looks like, and what CSP policies would be? So stuff like that is being worked on now, but the high level proposal is now in place. And then error handling capabilities, again, like besides classification, I just mentioned how errors can be handled, what kind of errors do exist, and what kind of solutions are feasible for different usage models. And this OEMs and CSPs have very different views of these, and it was very, very interesting to see HP, Dell, Meta, Google, Microsoft all come along, and including all the silicon vendors and memory vendors. So we spent a lot of time on proposing this and cleaning up what is really a recommendation, what is really feasible, and how our infrastructure proposal, the requirements that we are putting forward, can handle that. And then we gave some couple of examples, and then we went through a list of things because this requirements is really standing on foundation of existing standards. So we have identified some of those areas, and those are also listed here, that where the work is needed, right? So that's the next section. And that's pretty much it. For after that, we have basically some glossary of terms, some implementation notes, and our conclusion. That is pretty much all I have. Yes.
Yeah, no, I think I was going to
Question.
say this is good overview of what's going to the IC, and with this requirement specification that's being out there, what are the following spec where like every spec will refer to this? This is more like an overview or the top level kind of spec. Is that the idea?
Yeah. Yeah. This is the top level spec, and within it there are existing specs. For example, CPER is there, and Jeff and um, others have worked on some of those CPER pieces to accommodate uh, some reporting of hardware errors in that. Similar things are being done for memory errors and some of the newer developments in memory error handling and predictive analysis. So yes, this is a kind of a, for lack of a better term, like a wrapper specification or wrapper requirements that we expect all the stakeholders
Mhm.
in the CSP infrastructure to align with this and create their solutions around this. Of course, they'll still follow existing industry standards. For example, for memory error reporting, there's JEDEC requirements, there's JEDEC protocols. For OS kernel level, we have definitions, and kernel has tables and whatnot. UEFI has some definitions of their own. So those are the basic specs that we are next step we're working through and identifying what next level work needs to be done where.
Okay. Thanks. Yogesh, do you mind putting the link of this in chat so I can capture that in minutes?
Absolutely.
Let me ask on the call, anybody has any questions or comments on OCP fault management infrastructure requirement spec for which we got an overview here? The next step, Yogesh, this is going up to IC for approval.
Yes.
Okay. Anybody has any issues or concern? I don't think we need to approve it at the project level, as we can do things in parallel with sub projects. Okay. All right. Then thanks, Yogesh, for covering. Anything else from the hardware fault management sub project?
No, I think that is it. We'll be starting this, like I mentioned, other stuff is going in parallel. So
Yeah,
thank you
I
very
just
much.
put a note. Yeah, thanks. You're working on a set of specification. Yeah.
Okay, great. Thank you.
Okay, next one we can have is the second presentation is Lenovo Cloudflare on DCS-CM 2.0 module, product spec and reference design. Who is presenting this? Do we have presenters on the call?
Yeah, we
Sorry.
should.
Yes.
Yeah.
Oh,
Sorry, go ahead. To it.
yeah, we have I'm Stuart from Lenovo. Then we also have JQ Lau and Xiaomin Shin from Cloudflare.
Okay. So one of you, we have let's take about 10-15 minutes to go over the presentation, if you can share.
Okay. Can you guys see that?
Yep.
Yes.
Okay. Okay, yeah, like I said, I'm Stuart Nguyen from Lenovo. We also have JQ and Xiaomin from Cloudflare. We'll kind of take you through as far as what Project Argos is and what the goal of it is. Basically, it's as you'll notice, it's a TC SCM 2.0 base card. As far as the scope and objective of Project Argos, this is pretty much in line with the base spec, but our goal is to enable interoperability with many different HPMs. We will provide by providing the reference design. We're hoping other HPM vendors would be able to directly interface with our Project Argos SCM card, with the expectation that the firmware sets would probably need to be customized accordingly for the full interoperability. As part of the spec that we would provide, we would also contribute other materials, other design files that would include the DCSCM mechanical form factor details, as far as the faceplate, the locking mechanism and mount points, and JQ could probably dive in a little more details there later. Also the DC SCI interface, we would also contribute the pinouts, signaling that this would mostly, this does comply with the spec. As part of the faceplate, we would also provide the kind of our definition of the I/O connectors external to the card. For firmware, we will be providing a open BMC base code as for the main purposes of discovery and management to the different HPMs. The other contribution would be the hardware root of trust base firmware. This would mainly be used for firmware attestation for the BMC as well as the HPM BIOS. And additional documents that we'll provide would include the schematic reference, the bill of material, the stack up, block diagrams, and bootable device tree requirements so that the connected HPMs can ensure full interoperability. Okay, as far as the overview of what Project Argos is, like I mentioned, it is highly leveraged from the base spec, the revision 2.0, version 1.0. Excuse me. This would allow connection to a single node configuration. So our reference is implemented to support single and not the dual node. As far as mechanical form factor, we are implementing the horizontal EFF, external form factor. So this could live either the front or the rear of the server and support both the airflow directions. For the BMC SoC, we ended up with the ASPEED AST 2600. And as mentioned, for the various HPM vendors, we would expect some customization from the open BMC base code that we provide to ensure that full interoperability. For the root of trust, we are using the ASPEED AST 1060. And to tie it all together, the CPLD on the SCM we're using is from Lattice. It's the Mach X03. Okay, jumping forward, the block diagram. I mentioned all the critical ICs. You'll see here how they're connected. You'll probably notice that this block diagram has a lot of similarities with the example in the space spec. I would point out I guess the key differences here you'd see is the panel I/O, the faceplate part, as far as what connectors coming in and out, and JQ will walk you through that. The other thing missing here that we don't show is we do for the by4 PCI endpoint, we do reserve the connection for it, but as far as for implementation, we are not using it. Okay, jumping to the mechanical overview, I'll pass this to JQ.
Okay, thank you, Stuart. Hi everyone, this is JQ from Cloudflare. Continuing down this slide. So mechanical overview, it is compatible with the horizontal EFF specification in the base spec revision 2, version 1. It also uses a straddle mount connector coplanar to the HPM per described by the base spec. DCSCI card edge connector interface compliant to the SFF TA 1002 spec. It also have a removable TPM module that is fixed with a tamper-proof screw on the module. It can be mounted at either the front or the rear of HPM based on the chassis design and the HPM design. It does adhere to the OCP chassis bay opening requirement and provides sufficient contact surface for EMI solution. Next slide, please. For the front I/O panel, these are the I/O connector. We opt for mini display port because of space constraint. We kept the RJ45 for the out-of-band interface. We have a stack USB-A connector. One is reserved for a USB 2.0 interface for mouse and keyboard with crash cart. The other is for UART label with comp. This is to interface with the STM CPLD for debugging if needed to. And then on the card, we also have the power button, the ID button, as well as the system LED. There is also a power LED and an ID LED embedded inside the button.
Quick
sorry,
question. What's the ID button for?
This is to identify the chassis. So either someone remotely want to identify the chassis can blink the LED, or someone from the the data center can press the ID button for a remote person to confirm that that's a server.
Okay, thank you.
All right, next we'll also describe an internal lock mechanism. The base spec do have some language about allowing for internal lock mechanism. We take advantage of that mainly because the DCSCM module is not made for hot pluggable, and it does contain, once we implement a hardware trust or a TPM, it may contain secrets on it that we don't want it to be easily removable. So we implement our internal lock mechanism, and forcing someone who wants to remove it has to basically remove the server from the rack and then open up the chassis top before they can engage the lock and remove the entire DCSCM module. This slide basically describes the lock mechanism as well as the steps that needs to be followed to remove the entire DCSCM module. I will not go through them one by one. Next slide, please.
So one quick question on that. Yeah, when you say physically secure here, what you're saying is without removing or decommissioning the server, you cannot remove this module. Is that your definition of?
Not necessarily decommission, as I guess when it's rack, you cannot remove it just from the rack, because without the internal lock mechanism, someone can just unscrew and then pull the pull tab to pull the DCSM module out.
So it says it's as physically secure as the rack is.
Correct. As
Okay.
long as you can access the front side of the rack and you can pull the entire server out, then yeah, it's no longer secure.
Okay.
All right, the DCSCI pin definition, this also fully adhere to the base spec. We have the LTPI, the SGPIO, the I2C buses, one eSPI bus. We have the QSPI and SPI buses. The SPI buses are used primarily for the SPI ROMs for the BMC and the BIOS. We have one USB bus going through the DCSCI connecting the HPM and the BMC, as well as to the external port. We also have brought the PCIe bus through the DCSCI per the base spec. There is a PACI bus mainly for Intel implementation. We do still have that and terminate on the DCSCM. There is a JTAG that goes through the DCSCI, and then NCSI UART are going through the DCSCI as well. We also have a power button GPI signal going from the HPM to the DCSCM. This allows implementation where you have DCSCM on the rarer chassis, but the system spec still requires a power button on the front end of the chassis. So this connection allows you to have power button both on DCSCM as well as on the chassis. Any question on this slide? All right, next I'll pass on to Xiaomin to talk more about the electrical and the system firmware portion.
Thanks, Stuart and JQ. Hello, I'm Xiaomin. I'm a hardware engineer with Cloudflare. I'll quickly cover the power distribution of Project Argus. Our design has a power delivery board to supply 12-volt standby to the HPM. And we also, on the HPM, we have an eFuse. In the DCSCM spec, it says that the eFuse is recommended but not required. For DCSCM, that is locked with a screw. Our DCSCM does have a locking mechanism, like Jeff just talked about, but we think that it will improve the reliability of our design by implementing an eFuse to prevent things like short circuits caused by damaged connector pins, or things like our data center technician accidentally unfastening a screw and remove the DCSCM. So we have a eFuse. It is limited to 1.65 amp. Basically, that's limiting the power of the DCSCM to 19.8 watt. And then after, so the eFuse will deliver P12. It's kind of small on the right here. I hope you guys can see. So the eFuse will provide 12-volt SEM aux to the DCSCM. And then from there, we have regulators to regulate 12-volt standby down to 5-volt and 3.3 volt, and then the rest of the rails from 3.3 volt. Any question here? Okay, next I'm going to talk about the power states. So our power state and discovery sequence is compliant with the DCSCM base spec. We did implement a few additional steps that involve hardware root of trust authentication. So at G3, the step 0, there's no PSU input power. The only bias available is from the coin cell battery. At step 1, 12-volt aux is delivered from the PSU to the input of the eFuse. And at step 2, the DCSCM is fully seated. There are 2 present signals. Present 1 is put to ground on the HPM, and when the DCSCM is properly seated, present 0 will become low and enables the eFuse for the DCSCM. The eFuse delivers 12-volt SCM aux to DCSCM. through the DCSCI power pins. And at step 3, we have 5 volt SCM aux and 3.3 volt SCM aux automatically enabled when 12 volt SCM aux is up. At this time, CPLD, BMC, and hardware root of trust become powered. We also will have power for the HPM through the 3.3 volt. It is delivered from DCSCM to HPM through the DCSCI. And at step 4, okay, step 4 and step 4, 5, 6 are the additional steps that we implemented for hardware root of trust authentication. Step 4 is when hardware root of trust authenticates its own firmware image and boots up. And at step 5, hardware root of trust proceeds to authenticate the BMC firmware image. If the authentication passes, hardware root of trust deasserts the PFR reset signal to BMC and allows BMC to boot up to its own image. At step 6, hardware root of trust authenticates the UEFI firmware image. And if the authentication passes, then root of trust will deassert the PFR HPM standby reset to HPM CPLD. At step 7, BMC reads the HPM through on I2C bus 0 and checks the compatibility of the HPM. Our design does not implement the optional authentication IC on the HPM, so that's slightly different from the, it's not different, but yeah, so it's an option, so we decided that we don't need this. And at step 8, if BMC decides that the HPM is compatible, BMC notifies the DCSCM CPLD, and then DCSCM CPLD asserts HPM standby enable, allowing the standby rails on HPM to come up. The rest of the steps follow the DCSCM base spec, so I won't go into too much detail here because of the time constraint.
Are you assuming the HPM FPGA is self-authenticating? It doesn't need the ROT or the BMC to perform that before use?
Yeah.
Okay.
Okay. So I think this is, anybody has any other questions?
Oh, we have a few more slides.
Oh, go ahead. So,
okay.
Yeah, if you could wrap up.
Okay, sorry. So real quick, we have we're using open BMC firmware image on our BMC. The goal is to have a unified image across multiple vendors for interoperability. The device tree of the image will be loaded based on the information contained in the HPM through. And then for hardware root of trust, we'll use image based on ASP's Zephyr SDK. It's also open source on GitHub. Next slide, please. Okay, real quick, this shows the content of the HPM through. We have at the top, we have the mandatory common header area, and then the board info area and the product info area. We added the DCSCM multi-record area following the DCSCM spec. And then on the right, it is a breakdown of how the DCSCM multi-record area is for our design. Any question here?
Actually, Stuart, can you go back to the through spec page? I guess a question for the group here. The DCSCM type, the third last row, since this is a specific reference design, do we use a specific number for that field or just keep it at 0?
JQ, actually, I can provide some background on this. So on the spec, it says 0, 1 to FF are reserved. As of now, 0 is available. 0 means it's not any define type. So right now we have 00 filled in the group.
Yeah, I don't think that the SCM group was planning to try to have people register like you would in PCIe or USB, their SCM type, to have a universal SCM type field. And it's really the thing that doesn't matter is the SCM type shouldn't be there at all. It really should be the HBM type, which by the way is the native HBM type before it's potentially mutated by other things that plug into the HBM as you're on your way to determining the model ID of the system. So I think that field is actually a misnomer, that the HBM doesn't care about the SCM type. It should really be HBM type, so that
Right.
the SCM knows which HBM it is, so they can proceed forward to start engaging buses.
So is there clarity in the spec as to what it should be, or this is something that DCSCM spec should clarify?
Yes, the latter.
Okay, then it is what it is until they make themselves clear.
Okay. We do have also a through on the DCSCM that we can include some information in other areas before that spec is before the base spec is updated, and we can update the through accordingly.
Thanks for presenting this. Can you go back to the submission page? I wanted to just capture that. So this submission material you have listed here, what is it's already been submitted, or is there a plan to submit this in near future?
We have it ready. I think it's sent to this group only. We have not submitted to OCP officially.
Okay.
But that there
So
is plan to go to incubation committee by next month. So assuming that there's no revision required from this group's review, then we would submit it and go to the incubation committee after this.
When you say this group's review, I believe the review is being done in the hardware management module sub-project. Is that where it's happening, or where the review is happening?
Currently it's between Cloudflare and Lenovo. I guess this is the first time we are submitting specs, so we are not sure what the procedure is. It is reviewed by I think Mike and a few OCP folks on the structure and the legal content, but not the technical content yet. Who should we go to for that review portion?
Yeah, I think we should. So first, if you can send a link to this slide that I would like to put in the notes, and it will be good to go over the same DAC in hardware management module sub-project. And that's
yeah, you're the only one that really need to review it. So Chen,
they are
if you're
right.
on the line, can you take this into hardware management module?
Sure. What review process should we go through?
I think Shin, maybe the initial, all the submission material they are talking about here, it'll be good to start with reviewing that.
Okay.
I know that there's been others, like there was last year an official contribution from AMD, for example, on an SCM 1.0 with all the relative hardware collaterals that had, the SCM group had no involvement with that. So if it's just a submission, the SCM group probably doesn't necessarily, they're not in an approval path or anything like that. But I do want to say that it is very important, and there's a lot of greatness in here and a lot of alignment with what is going on with the SCM group that we would love. I know Lenovo's already tied in, but Cloudflare as well, to what we're calling this HBM Type 1 Common Circuits design specification that's kicked off, that instead of throwing like a de facto out there and assuming that the HBMs would be designing to the interfaces selected here, that it is a bunch of companies agreeing on exact usages from the base spec, which has a lot of options, to a single specific assumptions around a lot of those interfaces. So that would be a fantastic collaboration to get involved with that, because then it becomes the HPM vendors now have a single set of agreed upon common circuitry that help with that SEM hardware interop.
So, okay, so I have some process questions. So is this being contributed as a design file? Is that design files or design spec?
Yeah, it's contributed as, I don't know the actual language used in OCP, but I think they call it the product spec is what we heard. We'll contribute some design files, including the schematic, bill of materials stack up, but not to a full Gerber that someone can just take and go manufacture directly. We are assuming that based on Cloudflare's experience, our ODM has feedback that they want to choose their preferred vendor for some of the IC, some of the components. So they don't want to take it directly to go manufacture. Some do, some doesn't. So we leave it at schematic level. They can take a schematic, spin similar schematic, and go do their layout and bill of materials
Okay.
and Gerber and things like that.
So it's a reference design.
It's a reference plan, correct?
Yeah, so we don't actually need review of this. We can take it directly to IC. You and I need to have a discussion with Michael Shell as to exactly what form this takes, because it can't be a set design files until you have a product within 6 months, which is coming out. So there's all these requirements for design files. So
John, action should be them to sync up with you before the
yes,
submission.
yes.
Okay.
Sorry, who
All
was
right.
that?
This is John Leon.
John
Okay.
Leon.
So
He's
I am
our
the IC rep. Go ahead. I'm the IC rep for hardware management project, so it goes through me anyway.
Okay.
And Hevel, since we're running short of time, I wanted to give Bhushan wanted to just broach a topic here about a potential work stream or a new activity. So Bhushan, can you talk briefly about that?
Absolutely, yeah. Thank you so much for giving me the time. My name is Bhushan Mahendare. I am a dev manager here in Azure's firmware organization. One of the things that we're exploring is figuring out if there is a way to standardize connectivity to GPUs through the BMC. And I wanted to sort of put it out to you saying whether this would be the right forum to bring such topics to, or would it would be a better fit for some other project or so on and so forth. So the idea is to ensure that we are able to communicate with GPUs, as you rightly know that they are increasing in priority all across our hyperscalers, and how do we communicate with them out of band using BMC and so on. So that's sort of the question up front for this forum, and I really appreciate your guidance.
Yeah, so Bhushan, I think I did reply to you. This can either go to server or hardware management project. Maybe next step here, it will be good because one of the things we have been talking about, should hardware management project standardize this type of interfaces to devices, or have a common uh, kind of architecture for that. So from that standpoint, this will be applicable. Do you want to? I know we are short on time, but if you can create few slides on the proposal, and then if we can go over that here in the group, in the project call, that'll
Sounds good.
be
Yep. Yep. I can bring it to the next call. Not a problem. Yep.
okay.
Yeah.
I think the
Yeah,
ultimate question is, where are the subject matter experts, right? If your thing is very focused on GPUs and accelerators and all that subject matter experts are over there in the server project, you should go over there. If it's structurally, right, what should manageability from the BMC on down would be in general, right? It belongs here, because just as we define a breakfast profile, which every project can go extend if they want, and we define the baseline, is the same thing for southbound from the BMC. Is we would like to find the generic structure, and then each individual project with their SMEs, right, can go extend it for their particular platform.
Got it. Thank you, John, for your input. Okay, Himal,
yeah,
I'll bring this over next time. Not a problem at all. Yeah.
yeah. So let's discuss that.
Thank you.
Thanks. And I think other one is Samar. You wanted to just quickly. We don't have presentation, but feedback on RAS API. You want to spend a minute on that? What you were planning to cover in the next call?
Sure, yeah, I can talk about that quickly. So there is feedback from several ARM-based server vendors and silicon vendors that the current approach is not well aligned with the standard approach that ARM servers operate with for RAS management, especially for the in-band OS interactions where there is standardization happening in some of the silicon components, as well as the discovery for the OS to interact directly with those with the error sources. And on the hardware management side, there is general consensus that PLDM is a better approach than using a new MCTP type. So just all this feedback collectively, how can this be worked out with the current proposal? I heard earlier from Yogesh that maybe there is a sub-team starting. Is that the right place to have those conversations?
There is a work stream. Yeah. I yeah. So this here, Samar, for next, if you can create some. What are I mean current proposal? What's the feedback and what are the issues and what are the changes you would like to propose to the proposal? Then there'll be a discussion here. You can have that as well as participate in the work stream.
Sure, and
Well,
that
the
was
work
the
stream.
yeah. Go ahead. Sorry.
Yeah, go ahead,
Oh,
John.
I think the focus should be to start up this work stream. So we've talked about it. I don't think it's actually been started because nothing's been posted on the calendar. So
Yeah.
if that work stream was existence, right, I go sit with them and go talk to them, right, and go hash it out there.
So last time this was presented, I thought a CLA was needed to access the proposal, and I assume that work stream. Is that still the case?
I do not know the state of that work stream. So yes, my understanding was that it was going to be there was going to be a CLA around that. So have you asked for the CLA or?
Yes, we have been asking for the CLA, but maybe you know who's the right person to ask for the CLA? I guess I've been talking to Drew, but things have been moving slowly.
Okay.
So John, who
So I
is
thought
driving that work stream?
so I thought Antonio was driving it. So I don't believe I've seen a proposal to start a RAS API workstream, right? So last time when I created the profile one, right, there was a designated list of who's going to drive it and who will co-lead. So we need a document like that, right, to say, the hardware management project okays this work stream to be created and it will be run by this person until further notice.
So maybe I can help. I think Drew, I know, had been a little distracted, and Antonio, I think, was out too. So maybe it just needs a little bit of follow up if the slowdown is all you're experiencing. But I think I don't know of any change in the plan. But yes, CLA work stream is planned.
So Yogesh and Samar, can you guys talk offline on this to figure out how to cover the feedback?
Yeah, we'll need to follow this up via email or offline. But so we're about to run out of time. But before we do, so looking at the calendar, while the next meeting, Hemel, would be the day before the half day workshop. I'm not seeing anything on the calendar. I mean, we can't move that up a week or up or down a week because it conflicts with other meetings at these time slots. So I would say, given the amount of material that we talked about today and the amount of stuff we've got coming, I'd say let's go ahead and continue to hold the meeting
Yes.
next month.
Yeah, I think let's hold the meeting and then they'll also give us chance to sync before the
Yes.
workshop.
Yep.
Yes.
Since the workshop's got a full agenda anyway, so.
Yep. And we will cover all the updates we didn't cover this time in that next meeting. Okay.
Great.
All right. We are done here. Anything before we depart? Okay. Thanks, everyone. Thanks for the presentations today and thanks for the discussion.
Thanks, folks.